It's on screen. So first I will talk about assignment. I already upload our second assignment to D2L. So you see mainly we have two actually there's a two source code, but you will see I also upload the source code. There's a zip file attached with it. So mainly with first one is called a multi-process resource sharing. That's what we cover in our lecture. So it's kind of very similar to what we like refer to the PowerPoint. So it's just like simulate how it really actually working. We just need to implement the C file, how it works. So basically it's called the like producer, and we're taking the example as the producer and consumer. So it just helps you to know how it actually works, because we talk about we have the called the seminar weight signal like plus and then count. So you can refer to the PowerPoint and also just like for example, because actually all these we introduced like all this process about the operating system is not something new. And because sometimes they deal with the like low level, like sometimes working with the kernel. So basically for our operating system, we are not really like inverting or let you to create something new, just like we maybe use our another language. So no matter we're using C++ or I show you we're using the Node.js, Python, or other JavaScript, like Java, we just like simulate. We are not really like handle with the memory level or take care of the devices like those kernel level. So when we assimilate just this one, how can we apply to make sure control and avoid, especially for the multi-process, this one is like, how can we have a signal and then have a flag or like have a log to make sure we have a, like try to have a system call when we create multiple child. So we don't have a issue like goes to a deadlock. So that's why we try to do it. So that's why we create the semaphore to manage the synchronize between producer and consumer. So I wish this one, because even maybe you go through all the PowerPoint slides and we look at the source code, maybe it's really hard. So just have you have a chance to implement like from the code, refer to the code, then you are able to do it. Okay. But I will talk about this one details. And then just what do you need to do? Just complete the code, like fill some empty space. So I'll give you some hints. So what to, so suppose it shouldn't be that difficult, even though you look at the two source code I gave you, but actually the syntax is pretty short. So mainly it's the logic. So it, most of the time you may be just like stuck at, okay, how I make sure the system call. But all this you can refer to the PowerPoint or like some online resources, you have a answer solution. Okay, so that's why the assignment is not testing you how much you know programming, but just the understanding. If I can help you to understand it, it's good enough. Okay, so I don't mind if you like refer to some online resources or anything. Okay, so here's the first one. But I will go jump into the source code with it. And the second one is called the safe mode of mutex simulation. So this one will be the even the previous the lab I show you. We have the I upload. We have the called the worker, and also we have the main function. So if you remember, I demonstrate and execute. Also execute. So that one I show you as a Node.js using a JavaScript source code. to simulate how it works. So this time I just asking you, I already give you the structure, like using a C purpose. So you just need to implement is using the C purpose to fill out some certain statement, actually only few sentences. So if you know the whole logic, then you won't spend that much time. Okay, so that's why I try to put like two of them together as a one assignment. So let me know if you need more time like to finish it. I think I already give kind of like more than 2 weeks, but so you should have enough time to work on it. And for this one, we try to make sure, okay, this one is the symbol, the mutex. So ensure the safe access to share resources among the multiple processor. So that's what we learned. And that one is called the week 6 -2.js. And we have the worker. So I already upload to it. If you want to see how it works, also you can download that JS file to execute. So this one, we try to have a fork function to create multiple child process, and those processes will also send a message back to the parent, indicate like what it want to do to access the resources. So once we finish the updating the resources, we need to release it. So we need to make sure how can we like log in and unlock it. So make sure they only no other child able to access it. Okay, so just finish the code and submit it. When you execute, you should try to add some like output. So I also have some with the CL statement to print a message, but you can make the message complete. Okay, what kind of information you should print out? Okay, so just refer to my example right here. So the first one will be the safe mode. Let me use this one, enlarge it. Just go back to the Node.js file. So knowing the logic. So right here we will have a main child. So this child we will have a function called fork. So it's the system call. So we'll create the child. So for this one, I default we are number 3. So we will try to create a child 3 different child. And for this child, we also have a fork. We pass the parameter. The file is called the worker.js. But if you look at the source code I gave you, so I just put them together. So main and then the child process. So they're under the same file. So you don't have to worry about that. We just call it. And this one I already declared like the number of processes by 3. So it's calling is a loop. So we need to that means when you need to free up the line 1 of it, how can we call this system called fork to create a new child? Okay. So once we create, and then mainly is this part, the child process. So how it's going to do? Right here is the same. The child right here, I copy. So the worker.js will be right here. Okay. So when here, somehow I will check the type. So can I start to do that? Yes. So yes, I now check. Okay, is it locked? So if not yet locked, that means that I'm the first process or the child, the first one able to access it. Then I will set to true first. So if you remember from the PowerPoint we talked about the milk, that one is the example that simulate that one. So we always try to give the lock first. So accurate the lock. So I turn to true. After we make it true, then we can take the action. So that we call that like the critical. So if you remember, we talk about critical. So mainly the critical is I try to update. So we're saying to the parent, I say I want to update the value. So that's why you see the output right here. So let's say if I want to see the message resource updated, and then maybe if I want to modify like which resources or like which child, then you can also add the child information or ID. You can do that. You can modify the printing message. So right here you will see we have total have 15 resources updated. You will see sequentially because every time we pass one, right? Okay. And if you want to know, suppose they're in order because like when the process execute, right here, so we have a loop, so 5. So actually we execute 5 times this loop, like make sure checking every time. So most of them they will the same process will gain the same. So just like maybe you need to also like print out which PID, just get the PID. Okay, so which process is available to get the process to update value. Okay. So open by mistake. Okay. Okay. So you can like show me with the PID and then which PID update these resources. Okay. It may be this one is showing the value is update sequentially successfully, but you cannot see which child is like updating this value. But at least we can guarantee it's like no matter who do it, only one child able to update the value, send it back to the parent as one. And then next one, when they gain the access, they'll update. So it won't like comes out some error, say 1, 2, and then 3, 3, 3, and then 4, and then 4, 4, 4, and then maybe suddenly jump to like 10, 11, 12, and more than that. Okay. So suppose if you're working correctly, it should be 1 to 15. So there should be the result what you expected. And then what we should know. Okay. For this one, say every time we can just like add the value by one child or like one process or one step. That's it. Okay. And so what you need to do is how can we log it? So just do a log. So maybe you need to set a global variable. How can like to checking is a flag or like how can we check maybe true or false Boolean? And also like what's the shared resources? So that one we are going to update the value. So this two you need to declare the variable. And right here, just like we need to log it and then update. So the critical section. So what should we do? And then just try to after update, maybe you need to print out the message. Okay, maybe also adding your process ID. We have the ID, the child ID, then just like print out the ID, and then also what's the value you updated to. Okay, like this. And after you finish, after you say once you have the key, then you should remember release the key. Okay, otherwise we'll enter deadlock. So in the lecture we'll cover also talk about what's deadlock, and we need to avoid it. Okay, sometimes we talk about it for starving, so we're waiting for each other's. So if you don't release the other process, so we're waiting for you. So we end up called starving. So we are waiting for others, but you didn't release it. Okay. So kind of like you just like need to make a system call and then complete the part of several statements right here. So I believe it won't be that difficult. Okay. So this will be the safe mode. And also you can refer to my Node.js file. And then the one is called the multi-process resource sharing. And let me copy all the source code and enlarge it. Okay, right here. I will look at this part and then right here. Okay, so we have two function. So one is called the producer and consumer. Last time just like follow the PowerPoint the flow say already we have talked about the producer and consumer. That one's like based on the remember this one. So we need to implement with the called the signal. We need to have like the same weight and same signal. So we need to increase the count and pass the value. So try to look at this. This one may be slightly challenge, but pretty straightforward, actually, pretty straightforward. So I will give you the hints, and the hints will be right here. So we need to wait and then check. And then after you compare the weight, maybe you need to lock the buffer. So this one, if you remember the producer and consumer. If you remember, we have the buffer table. Okay, so after we log it, then just try to execute something like add pass the value. And then after you finish, then remember just to do the same, unlock it, and then just do the signal. So refer to the purpose. And one side is from the producer. So another side is the consumer. So the logic is pretty similar. So just have a signal like weight, same signal, and then update the value, and that's it. And for the details will be right here. So if you want to compare it, just like follow the PowerPoint slides or trigger line, then I think you'll be okay to finish this part. Okay. And hopefully you can have a like better understanding, because the logic is always over there and we never change. So that one is the best way, as I calculate, the best way to fix this kind of issue. Okay. And that's why we don't have another second solution comes out to our lecture. Well, of course, like when you see something, maybe we'll say solution 1, 2, 3, but when we comes out different solution, because we didn't really fix those situation, like let's say the deadlock or the mutual exclusion or this situation. So that's why we need to modify our solution to solve it and avoid the deadlock. So just kind of here's the 2 assignment. So just finish it and then try to print out the message. So you see where the CR. So I give you an example. You can make it more details. You can see his ID and items. So you'll know which one, like, is it belongs to the producer or the consumer? So or the name. And that's what you need to do, and then compile, run it. Okay. Okay, let's go. And that's it for our assignment. Just keep going. Okay. So last time we stopped about the primitive, and we will move on about the next one is called the monitors. So for monitors, just like look at the alternative software like locking mechanism. So it's specification about the might be less prone to quick incorrect sharing or concurrent. Okay. For monitors, we try to like construct for something for the programming language, provide the equivalent functionality to that the semaphore or like easier to control. So we will implement in a number of a program language, so we can have different type. She's like, okay, we can do it. Also have been like implemented as like program library. So that's what we do. And then software modules consist of one or more procedures, initialization sequence, and local data. And the characteristic, like one is like the local data variables, like are accessed only by the monitor procedures. So they are not by any external procedure. So there's a, and then if they are processed that enter the monitor by invoking one of its like procedure. So just like we create called a monitor and then we create some procedure, just like internal. We can create it for like sometimes just imagine it, sometimes we call the library, right? So those library would be the standing under monitor procedure. So only one process may be executed in the monitor at a time. And any other process that have invoked the monitor are blocked. I'm waiting for the monitor to become available, just like we have that. Okay, so every time we only execute one process. And after that finish, then we execute next one. So maybe we can have like a queue or waiting for it. And when we do, we also one thing called a synchronization. Synchronization just using a condition variables. So we connect with the monitor, also access, but only within the monitor. So they say, and then condition variables are operate by like 2 functions. One is called a C weight, and then one is C signal. Okay, just remember. So we have one is called a C weight. So we C weight using to suspend the execution of calling process on condition C. Okay, so C is called the condition. Okay, so C signal. So we put it back is like that we assume the execution of some process block after C weight on the same condition. Okay, So when we implement, we just calling these two functions. So this one we already have a procedure to handle it. So when we have a look into the structure of the monitor, so we see we have queue. We have a queue, and okay, so for monitor, so we have some, like we say the local data, the condition variable, different procedure 1 to k, and then we have some like in initialization code right here. So under a monitor, because every time we only execute one, so all of them we just like in waiting. So if I run the first one, I have a condition, let's say C1, I call it C1, finish and see signal and come back. And then maybe I have another process, just like C wait and again. So this way you see, okay. And then if I have something like urgent queue, so this one is more specific. So for regular way, just normal way, we have just like condition, so waiting in the queue. But if we have something like urgent, so then we'll create one more called urgent queue. So we just like wait, and then we have a C signal and do it, and then run this one and put others. So just remember, every time for monitor procedure, just only one process. Just make sure, just one. Okay. For the problem solution for this one, we using the monitor. Maybe it looks pretty small, so let me enlarge. Or you can look at the PowerPoint. So right here we have a monitor, just called the bundle buffer, and then we have the child, we have buffer n. So this one have a space, it's more like this array for, right? And then is a pointing is a pointer, so it's a next and next out. So it's just like have an array buffer. So we think because this one is using the C purpose. So it's like because that's why it's called using a char. So when we decay the array, so it's a complete string. So this, and then we have a count. So how many items inside this buffer, and then we have condition called not full or not empty. So it's a checking. Okay. When for this one we implement a function called append and I'll take. So append will be, let's say if the count equals to n, so it equals to the size, then I need to see weight. Okay, so I need to like put it into, is a not full, the condition, let's say this one called condition is not full, and then see weight. And if we are allowed to do that, that means we are okay, then we can move the buffer next in and then input this value. And then next in will be +1. So you will see, because this one is the queue. For Q, then we would like modules by n, so by remainder, and then come +1. Let's do, and then finish more item in buffer. Then we will try to do the C signal. So that's always do like C wait and C signal. We leave it and put the not empty. And we work on any other waiting consumer. Okay, and then one more is the take. So we just check, okay, is when we take something, So it's a kind of like extended. So you see producer and consumer. So this one is the same. So I'll make sure this one, the edge case checking. So is it the count equals to 0? So if nothing, I will put the C rate. So just wait. And then this one is called the not empty. Okay. And if we process it more than that, that means we are allowed to read it, or just like call it take, okay, or consume. And then X equals to from the buffer called next out. So we have the array, and the array we have two pointer in and out. Okay, so they are not really like written exactly the same character because they can be in synchronized. Okay, maybe out is right here, in is right here because it's like by the end of the queue, right? But that queue can be, so if you look at the location next in, we modules by n. So do you know how it's working? Actually, it's a circle queue. Do you know what is circle queue? Circle queue
is where you put it in, as it keeps going, it's going to be back.
Yes. Yeah. So that's why we need to, because if we're not using the circle queue, because we cannot create an infinite POI, right? Not doing that. And also it's a buffer. So the buffer will limit the size. And that's why we have two pointer. One is called that the next in and next out. So when they reach by the end of it, then we will using modules end. So let them move back to the beginning of the pointer. So we can just like thinking, let's say the end I say as like 100. So we can say for 100 char. Okay, we say the letter we input, okay, char. And when we goes to the 101, so it go back to the beginning, the first one. Okay, so that's how it work. So when we take out something, just we will minus the count, minus by one. Just put something in, plus one, minus one. Then we take something out. Okay, so then we have a called the C signal and then not full. So just so you see, we have different condition. Just working together. And right here, by default, like initialize like next in, next out, 0, count 0. So everything just beginning at the same time. Okay. So in, out, and count will be 0. So depends on array. So once if we have nothing, can we let's say for this condition, if in the beginning, can I call the take function? So after we initialize, then if I call the function take, so what will this program do?
If you've got nothing in the buffer,
Mm-hmm.
you're gonna wait until it has something in it.
Mm-hmm.
It's gonna set that X value to the next thing that's in the buffer. It's
Yeah.
gonna implement it.
So right here you see if I see the count equal to 0, that means that if you try to build a buffer, like we try to read something like the consumer and then the producer, okay, the consumer try to want to take something, but the buffer is empty, nothing. Then we will put it to the C wait, the monitor. So if you remember the monitor, we only execute one process at a time, and then if nothing, then we put it, just wait it over it, okay, in waiting queue. Okay, so when we are waiting, just like keep waiting until the buffer, we inject something. So we will just like see signal, okay, when it's not empty. So when we do something, okay, it's not full, okay, and then yes, okay, when now we have a signal, it's not empty, then we will, okay, then I'm able to do that. So X will get it from the buffer. So the next out will pass. Then we will pass one. Okay, move to the next one. Okay. And because it could be possible that I can like have take more like that I say the CL is but it's circle cube, so it's possible. But when you keep executing, maybe not by the end, and it shouldn't be like CL the next like before the next in is empty value. Just make sure these things. Inside the producer, so it's a idea right here. So it's same producer and consumer. So we have the char x, just like local variable. So we have a while loop. So you know while loop is like for executing, right? And always true. So we try to, for producer, we have a produce function. So we will produce x, and also we'll take function x, and then we have called the function like append x, and also we have the consume x. So it's the by default right here. Mhm.
In the take function, why is the next out plus one on this?
Okay, because I saying the next and now, so anybody can get y is plus one modules by n. I just make it really simplified. So I have, let's say in the beginning, call it next in and next out, and we have the count. So everything start with 0. So right now I'm pointing to here, and I'm pointing to here. So here's when we initialize the state. Let's say here we have the producer and consumer. So I just ignore that one like calling function. But when we try to always the situation, because like right now we already set the condition. So we always can make sure we have to read something first. Let's say I read the character A. And then we will append the value, right? So after we append the value, then we'll this one plus 1. Okay. So CL will still stay. So CL will still stay on the first item, but this one, the first thing will pointing to the next one. Okay. CL. So when we need to take something, then what's next? So because right now you ask why the next L plus 1 modules n. Okay, so when I keep doing so, why not? Because I point to 0, because I in my buffer I know the first one I have item. That's why it's allow me. Otherwise, I will stay into stay the C weight. I'm not allowed to read anything. So right here I will keep reading. So just like keep going. So after I read the item, I move the C next out to 1. Okay. Like this. Okay. So it will be back to the initialized condition. Okay. So in this condition, if I have no pen or I have no produce, then can we do anything? No. So we'll still stay in the C weight. Okay. So let the next one just C weight. Wait for the consumer. I will put it to waiting. So I cannot do take an action. I will wait until I'm able to do it. So I just like until this all this everything goes like first. Suppose the C in will execute first. Okay. So let's say right now I'm 3. And then maybe number 2 CO also, but this one should be 2 like this. Okay. So right now it's right here. I say already put A, B, C, D. Okay, right here. So this one's empty. Okay. Well, now we need to look at the C in first. C we have the because we already explained why we need to using the circle queue. So I say what circle queue, right? Because we will go back and use the first one. So we need to using modules. So let's say right now it's the 3 plus 1, and then modules 4. Right? So what's the return rate? Okay, yeah, so it will go back to 0 again. Okay, so this next in. How about maybe I already finished the last one. I will take the next out is 3. Okay, so the same things because I already pointing to this one next out, right? Then after I consume it, then I need to go back to the head of the queue, the first item of the queue. So I just like using the same way. So plus 1 and modules by n. So I can bring it back to 0. So that's how the circle queue works. And then the buffer is just like making a whole circle. Okay. Of course, n can be like any size. I make it simple. So no matter the n is 10, 100, 1000, it's still working in this way. Okay. Got you. It's good. Okay. And right here, then the next is about the message passing. So for the message passing, we will introduce a concept was the synchronization to the message passing mechanism. So when we are passing the message, So the process will interact with one another's, and then two fundamental requirements must be satisfied. One is the synchronization, and second one is the communication. So for the message passing, so it's one approach provide both of this function. So all this we will working for all the distributed system and share the memory like multiprocessor or the uniprocessor system. So they should working. Okay, message passing, the actual function normally provide in the form of pair like primitive. So send and receive. Send, we need to know the destination and then what's the message, and then from receive, we need to know the source and then what is the message. So this one. And then the process send the information in the form of a message to another process designed by the destination. So also the process receive information by executing the receive primitive that indicate the source of the message. Actually right here, the definition and content. So just remember the function send and receive. Receive, like we press like first parameter is the destination and the message. Receive what's the source and then the message. Right here, when we for sending the message, we have like synchronization, including we have block, not blocking, receive block, not blocking, and then test for arrival is one more thing. And then address like direct will be like send, receive, expressive, implicit, and then indirect for addressing will be static, dynamic, ownership. When the format of it will be like content, length, like fixed, some variable, queuing, discipline, like first in, first out, and then also priority. So all this will be included for the message passing. So the one you say the synchronization, right? The synchronization, including the send and receive. Only one difference is that for receiving, we will like test for arrival. So here's the communication of the message between two processes imply some level of synchronization between of two. Okay, so receiver cannot receive a message until it has been sent by another process. In addition, we need to specify what happens to a process after it issue a send or receive. Okay. And we will see like blocking send and blocking receive. So it's one of the included for the message passing. So both sender and receiver are blocked until the message is delivered. Okay, so until it's really delivered, then we will set it like to unblocking. Sometimes it referred as the preventive versus. So allowed to like the time synchronization between two processes. Right now we're talking two processes. But then how can we apply maybe we have like three processes more than that? Okay. So non-blocking send, and then what the situation is non-blocking send and then block the receive. So although the sender may like condition, then the receive is blocked until the request message arrive, right? So this one. So we allow us to send one or more message to variety of destination as quickly as possible. So because we are possible to send it into different destination, okay, and process must receive a message before it can do useful work. So for this one, I can send to different. That's why if I have multiple processes, I send a message to different one. So after I send it, and maybe I confirm, then actually I can sending, yes, I need to put them in the block. But after I know, okay, I already can send to different, then I can allow me to change to non-blocking status. So I can send again to another destination. But for other receive, I still block it until I really confirm I receive it. Okay, so here's the situation is allowed. We can have non-blocking and blocking, but this one working together. And if we are both of them are like send and receive for non-blocking, so neither need to wait, so they can just send it. Okay, and then another part is the addressing. So addressing is like schemes like for specify the process in send and receive primitive fall into two categories. If you remember the table right here, we have called the direct and indirect addressing. So for the direct addressing, so we just like send a primitive including specific identifier of the destination process, and receive the primitive can be handled in one of two ways. first one, we can just like require the process explicitly design it ascending process or the implicit address. So here, so the source parameter of the receiver, like primitive process, a value. So return. So we base on the one return address. So when the receive operation have been performed, so it's the implicit. Okay. And then we call it indirect addressing. So messages are not sent directly from the sender to receiver. So they are like sent to a shared data structure consisting of a queue. So here's one's called a mailbox. So we're not really directing sending. So right here is an example of the indirect process communication. So let's say I have the sender and then the receiver, right? So you will see from sender, I will send it, so the mailbox will keep it, and then for it. So you will know we have different protocols for the mailbox, right? SMTP, POP3, yeah. So this one, like one is like for us like to connect to gateway, like one is for sending and then one's for receiving. And for the mailbox intermediate. So from the sender, I only know I send it to the mailbox. So it's the destination. And then from this intermediate or the middleman, we receive and for send it to the receiver. So that's why we call the indirect process. It's not from source to receiver directly. So here's the graph for the one-to-one. If we have one-to-one, then we ask the question, is it possible to have multiple? So of course we can have multiple way. We have different sender account. So just like email, you know, different user can send an email to you. So they all go to the ports we allow, and then you can go to yours. And to kind of just break down, and then from one source, and then send it to the many to many, and then the receiver can have multiple receivers. So so the final this one, like in reality, is how it works. So we have multiple senders. Also, we have multiple receivers. So all of them, they go through the mailbox. Okay, that's how it works, like for indirect process communication. And for the general message format, so this format is like how defined. So just for you need to remember, you need to know. So we need to define for the header, we need to know the message type, what's the destination ID, source ID, and then what's the length of a message. Also the control information. And then in the body, so it will be the content of the message. And we will check it. So here's the same. How can we apply this knowledge, like the mutual exclusion? So for this program, let's say I have a number of process n, and for the function we have called p, and then we were taking the parameter integer I. So right here we will create a, like, let's say mailbox, and then have a box, and we have multiple. So it's kind of the same idea. We using the system code, the creating the child, you know, is the fork. Okay, so once we just like always true, that means that we are looping. So in the program, we are using while, is like always running as a service. So when we execute the receive, so I will check, okay, the box and then the message. And then we will execute some like certain critical sections. It is not important in this moment, and then we'll send it. So we will put the box and message. And if you remember, we say we have the send and receive, right? So send and receive, the structure we always will be right here, destination message, receive source and message. Okay, so you see the format, so we always put a port. So because we talk about the mailbox, so the mailbox that where we found, and then which one we need to forward to. So as a middleman, okay. And then we have the message passing. Here's one more example. So it's the same kind of producer and consumer. So you see it's the same idea. So you see always like producer and consumer. Because like with no producer, the consumer cannot do anything. That means like if I don't send you a message, then you will never able to receive a message, right? So that's why we need to do the same. Maybe we'll set the capacity, or like in the beginning, maybe the message will be like empty or null. So here will be the same. So let's say I have create a mailbox, produce and consume, and then just keep sending it. Okay. So we will do the same. So when we receive it, I will receive from the produce and then producer, and then with the message, and then we will call the function produce. And if you remember the produce, it's the same logic. Let me go back to the one we talked about. Okay. So it's a kind of like same logic. So it's actually it's the same like circle queue, and the buffer just became the message one, the message array. And then when we have a new message, we'll pass one, and then put it, and if no, we can put a signal, same idea. And then if we have the receiver receive it, then we make sure that do we have any the count is equal to 0, that means no mailbox. If we do, just put it into the waiting for it. So we will check until we have it, then we just get the mail. Okay. That's right here. So we call it consume. So if we able to receive it, then we will just like, okay, we can send out this one. If we cannot read it, we cannot forward it from that. This one is what the mailbox do. So we will see for producer, I need to receive and send it. And for consumer program, I need to receive it first and send it out. So here, like because all this the same way, the idea, because I'm the middleman. So I will always like make sure I receive certain content first, then I can send it out to like forward to. And for consumer, it's the same same logic, because the consumer is always the one like make sure what I can receive. Okay. And then if I okay, then I will run the consume. Okay. And then one more there's another case is called the readers and writers problem. Okay. So this common design. So we actually is a common example. Also, I have one more source code, but maybe we don't have time to cover this one. I will do it later, but we will go through these theories first. Okay. So for this one, we present a synchronization issue. So for the reader and writer problem, so for the data area share among many processes. So that's what we know. So some processes only read the data area, so we call it reader, but some are only that write to the data area. Okay. Just imagine there's the memory, so we have the variables, right? Some the process will only read it, some we have to write to the data. So just like what we created a function that assign equals to something, it's writing. Some only read the value. Okay, so the conditions must be satisfied. So any number of reader may simultaneously read the file, and only one writer at a time may write to a file. Okay, so when a writer is writing to a file, no reader may read it. So let's say we have the condition. So simplify. How would you implement? Always only write one writer to write the file, and we have multiple reader, so we don't have to limit it. If I need to read the file, I can read it, but only one situation is, what's the situation? Yes, you have to lock it. Okay, then just share idea. If I need to implement this one, how will you do? Always like start with the scratch. We already have a solution, like yeah. So, but if right now they have no idea, then how can we?
It'd be pretty much the same thing as the note thing, right?
Yeah. So actually, all these are pretty similar. Okay. Yeah, and then
So instead of like a specific memory
okay. Okay, let's say we think about writer first. So writer, we always have a while loop, like always choose, and what should we check? What do we need to check something? Okay.
I guess we're checking for a note, but we don't have to check for if there's no note.
Yeah, for each. So if you remember, so that when the milk, that means is the waiting space, right? The data's area, right? Okay, so that one's the like, can I write something in there? Then how can I guarantee it? Because we can have multiple writer, but every time we only have one writer is allowed to write something, write the data into it. How can we make sure that only one writer can write? That when we think about the writer side, like based on what we learned, like before we talk about so many examples, then how can we guarantee only one writer? Yeah.
The writer. So they check if there's like, if it's locked, if it's not locked, then they write,
Mm-hmm.
but they lock it while they're writing. So then other writers, when they check, it'll be locked. And then when the writer is done, then it unlocks it.
Mm-hmm, mm-hmm. Yeah, just wait. Yeah, so we will apply like what we learned is like wait way. So you say signal or like receive or put like C wait, C signal, same like the same wait, same signal. So they are all these methods. So I will check. So if I have a log, like something we can using the log to check. So this idea, okay, this is a writer side. So I would just say log. So when I get the log, then I can try to write the data. So it's called a critical, right? So if we remember, we just like ignore it. So it's called a critical session. We don't care like how we actually write into it. Maybe we are call a function to write to the buffer, like it doesn't matter. But we just need to, okay, unlock it. And this part is for writer. Okay, jump too fast. Okay, okay. Okay, so this is a writer. So every time just like have a log, we just say just a flag or log. Just make sure every time I can write it to this area. Okay. Then how about the reader? So we need to think about the reader side.
So the readers would also be checking the writer. When he says a writer, or a reader may not read if the writer is right.
Mm-hmm.
So they have to check this box, because that means that the writer is right. And then if it is,
Mm-hmm, mm-hmm.
it's the same thing, but instead of checking for other readers, they're checking for themselves. We're also checking.
If like because this one the condition is like because we have the called the writing area. So then do we need to consider just a question like consider, okay, let's say, okay, taking this one. So I have a reader and writer, and then let's have a log, right? So for multiple writer, we check if I get the log, then I can write. So if I'm writing this part, but for the reader, I have my reader 1, 2, 3, but I'm reading the location buffer 0. And how about this situation?
So the writer will only block that specific spot that they're writing to.
Mm-hmm. Okay.
You understand?
Yeah, so it's possible. Yeah, so can be, yeah. And because right here, actually, we say we have condition, actually kind of like two conditions. Right? So first thing is like all the readers can any numbers. That means that at 1 or to n, they are allowed to reading same time. So they don't control or limited by the log. Okay, so we don't have that. So if they want to read, they can read. Okay, same time, simultaneously. So it won't affect because the value we reading is not modified. So only one thing is that once they write into a file, so it's not allowed to read it. So that means I need to check is this file. Oh, well, I just put in the location, but when we talk about the file, then we need to think about. Okay, so is under status writing, then we are not allowed to read. So just simple, right? So if I want to read this file, then not allowed. So here's the source code. So we have the read count. So and then we apply the same idea, the same method. X equals to 1, and then WCM is equal to 1. So we have the reader and writer function. So based on the writer, so as what we discussed right here, so we have the while loop and then just the wait. So if we are allowed to do that, then just wait, right? So once we finish, just do the signal. So release it. So pretty easy. But for here, first I need to wait. Are we allowed to it? Then we have a read count. So plus. So read count equals to 1. Then we will put it to the wait. So this is one more condition, right? So that's why we say, okay, 1 is for waiter, and then once I make sure, okay, we waiting for it for the, if they're writing something in, okay? So if no, then we just like do the signal and then we can read it. So finish it and then just like run away and then just reading come -1. Okay, just like, okay, I'm done, I'm finished reading, I'm leaving. So, but if the read count equals to 0, then I also have a put a signal, this one, and then same signal equal to exit. So you see, right now we are applying actually for 2. So we are not only from the example, if you see before, we will because we have 2 conditions. One is like the writer writing to it, and second thing is that when we have multiple, they can read at the same time, so they're allowed to do that. So that's why we're putting 2. This one is like mainly for the reader. So the reader we have have a priority to do that. Let's say if another one we have the writer have the priority. So right here for reader, similar wait and then wait and then wait. So we have 3. So we are getting more tracking. Okay. So when we really allowed to access, then the read count +1. And if when the read count equals to 1, we just send to wait. Okay. So like this. Mainly this part we are looking for the writer. So we're setting one parameter like and wait. So if we are allowed to do that, then we will just like wait count +1. If it's already equals to 1, then we just print wait. Okay, so done, and then put a signal, and then say wait, and then we can write the unit. Just knowing the structure. Later we will have a source code. I will like give also same source code to simulate, so you will know the details of this one. So you know the sequence. So far right here, I try to cover. So the last one will be here, the stage of process queue. So the readers only in the system. So it will be like have a WSEM, so they want to set and then no queues, or like if the writers only in the system right here, so will be all set with the WS, also the RS, the one you will set, and then the writer queues will be WSEM right here. So we'll see. And then the both read the writer with the read first. So they will say the WS set by the reader, and then the read RS, that means like the reader they want already set by the writer. So because they will cross each other setting the opposite. So all the writers queue is on the WS, the writer SEM, and then one the readers queue will be the RSEM. So others will be on the Z. Okay. So that's why we see they create one more the set. Okay. And then both readers and writer with the write first. So write first will be just same writer and reader. So will be here they are all have a writer and writer, they were all set by the RS. And then writer have a queue under write WS. And then one reader will under the RSEM. So right here, and then other with the queue or still putting under set. So right here, we will just depends on read first or the write first. So the priority. So it depends on the priority. So we'll change reading first, just like writer and reader will be putting the set by the reader, I will set the writer W, and then the writer will set the R right here. But if we let them to have a write first, just like writing something, because for this one, it's possible we can read some slightly different producer and consumer, because we have to produce something and read it. But for reading data, it can be possible we have no value, right? Just like when we writing the program variables, we will get something null. So that means like we also will read the variable over there, the file. So it could be null. So just like depends on which one we set just be careful and pay attention with like if we say reader and writer, but with like which one comes first. If write first, then will be both the writer have a right to set the WSEM and RSEM, these two variable first, and then kind of like other things will be pretty similar. Okay. I have the source code right here. Reader and writer. And not this part. In the main function, we will do the same. Let's say we create, we have 3 readers and then 2 writers. So we initialize it with the like using fork, the system call. So create a child, and then with the reader, and then also we create the writer. Okay, just like put them together, join them together, and then after we finish, just destroy it. Okay, just clear memory. So here's the main function. So we just need to look at the reader and writers. So we can just like pass any maybe void argument. So with the starter, when we're passing by the address, it before in the beginning for here we have a readers log, right? So we're passing the log. So this one, so the writer, and then so this one maybe I say okay, so reader is reading, so right here. So we can't say sleep. Sleeping is like pretending. Okay, so we need to, it's the time for like access the data. Okay. And then after it finish reading, then we just unlock it. Okay. And for the writer, so right here I will check like is the reader is locked. Okay. And now then my the writer is like writing. So log, and then maybe I finish writing and then unlock it. So this one is the first one where I try to simulate. And here's the example. If you're interested, then you can try to execute, and I can like and look into the details. Also, I will do one more right here. Okay, so because you will see everything right here actually is sequentially. So because unlucky it's just like simulation. So we just like execute one by one, and then we do the system call. So you say if we set the beginning right here, well, we try to create a reader first. So we will see the first one, the reader 0, so the child 1, 1, 2. So below we try to 3. So we try to make the read. Okay, every time. And after I finish, and then we have the writer. We have 2 writers and then try to write. Okay. Here, so that's why for simulation, you always see the printout message always like sequentially. But for the OS, when we really need to handle, because they maybe have different time. Because right now, because we under the OS, and then on top of OS to simulate the OS. So that's why the result always like coming in this format. But when it's really working in the situation of OS, maybe we are coming, okay, maybe readers try to read, and then maybe writer 0 is writing, then for others we need to wait for it. So the sequence may be different. Okay, so but this one is like limited by our system call, and then we put it to the stack and stack execute with the queue. So like sometimes because the heap, so when we execute the process, the program, so it always comes with this format. Okay, so it's kind of almost the time about this one. Any question for this one or confusing? No, yeah, just memorize it. Yes. Because this, like I say, always like standardized. We have a solution to fix it. So remember it, and then I will try to give you some exercise practice. How can we implement? Then help you to knowing better. Maybe some questions like this asked, you can think. So you know how to handle that rewrite this one. Okay, and that's it for today's class. Oh, yeah, let me see.
P5, so please similar.
Modules.
Okay, I get to-
So now, okay, that is. For the modules, I will, sorry, I saw some message. Okay, maybe next time I will, have more time, I will explain more about what's the modules. Okay.